Hey everybody, the problem I'm going to show you today is similar to an SMO Junior problem I think back in 2007. I'm going to write down a result that one approach is just to expand this out, okay? Now A, B, and C are the zeros. And so if you were to take the time to onerously and tediously and in an error-prone fashion expand this object out, you would find that minus the sum of the zeros appeared in front of the x squared term. That is to say, the coefficient of x squared would be minus the sum of the zeros. And that's pretty easy to see. I can show you at the very end of the problem. I'll show you why that's true if you don't know, but we're going to assume it's true now. So again, an approach is to expand all this out, which is you'd have to know what 23 cubed was, right? And who wants to do that, right? It's possible, but if you did that, you would find your answer via examining the coefficient of the x squared term, okay? Now, a much easier approach here is just to rewrite this and note that 23 plus 5, in other words, we're going to try to exploit some symmetry here. All right, now that motivates us to make this substitution, u is equal to 14 minus x, because certainly 14 minus x appears here, and then halfway between 23 and 5 is 14. So this substitution is very natural, and you can see what happens here. And this is a kind of a classic example of alternating series where you are going to have, in this case, there's 4 terms in each of these expansions, right? 2 of them are going to be additive inverses of each other, as we see right here, 27u squared minus 27u squared. And what else do we got here? 9 cubed. Notice we never have to know what 9 cubed is equal to. All right. Now, with this substitution, actually, when everything cancels out, you end up with this. I'm sorry. When you cancel everything else, you end up with this, and this is equivalent to this. Now, the big deal right here is to note that there's a missing u squared term. So in other words, you can think of a 0 u squared term being present right here. And again, if you let u1, let me just write this out. If u sub I equals 1 to 3, or roots, right, would be the roots of this new polynomial expression that's equivalent to the first one that we're trying to solve, okay? So what we know is that the minus the sum of those zeros or roots are equal to 0. Now, y'all, again, I'll run down here real quick and show you. It's based on this. Okay, it's based on this. We're using different letters, but it's all the same thing. You see how minus the sum of the zeros is the coefficient of x squared when you expand this object out, okay? So anyway, what do we got going on now? All right, now, so what are we going to do? We're using that substitution. Remember, we have u is equal to 14 minus x, u equals to 14 minus x. Okay, so we're using that right down here. But isn't this cool? You see, this is 0 right here, right? And so what we get right here, if the left-hand side is 0, we get that 14 plus 14 plus 14, which is 42, 3 times 14 is 42, is equal to a plus b plus c. Isn't that cool? So the symmetry here made our task quite a bit simpler, all right? And that's the answer to our question. Remember, we were looking for the sum of the zeros. Well, A, B, and C are the sum. So, or A, B, and C are the zeros. So the sum is equal to 42. Okay. And y'all, again, I think this is an immense labor-saving way of doing things. You exploit symmetry. And again, the alternative would have been to expand. Look, just think, you would have 64 times the expansion of 14 minus x quantity cubed, 23 minus x quantity cubed. You'd make a mistake in there somewhere. You'd have to know what 23 cubed was. Fair enough, you could use a calculator, but still your constants are too large, okay? This way, you see, we take advantage of a lot of nice cancellation, and we get a relatively simple cubic with a missing squared term. But that missing squared term means we have a coefficient of 0, and we can equate the zeros of said equation to the 0. Okay, we can sum up the zeros of this and then we use that via the substitution, and the result just pops out so easily. So again, this is an immense, I don't know how you measure complexity, but this is not as complex or computational as, again, just expanding this entire thing out. Thank you for viewing.